Hi everyone, thanks for joining me today as we look at being able to graph inverses. We are going to find the inverse of a function both graphically as well as algebraically. Okay, so now if we want to find an inverse of a function graphically, all you gotta do is graph your original function. We're going to make a table of the ordered pairs just to kind of help you to keep everything in order. We're going to switch the x and the y values. You're now going to get a new table of values here to sketch a graph. And then also remember that the inverse of a function is actually a reflection of your original function over a line y is equal to x. Now, if you want to do the inverse algebraically, well, same thing. You just have to switch the x and the y, and now we're going to solve for a new y to get a new equation that's going to represent our inverse. So let's look at what these things mean by looking at several examples. So the first example is we're going to find this function, f of x, 4x plus 1. We're going to find it graphically as well as algebraically. So the first thing we want to do is let's graph our original function. So my y-intercept is 1, slope is 4 over 1, and then I'm going to make a few dots, and then I'm going to make my line. Well, now I'm then going to take those 4 points, however many you have, and I'm going to make a table of values. So from there, what we're going to do is we're going to switch to find my inverse. I'm going to switch the x and the y values. So what that means, my x values now all become my y values, and the y values all become the x values. So here, this new table is going to give us a new set of ordered pairs so we can sketch the graph of our new function, which is our inverse, plot those points, and then make your line. Now remember that the inverse is a reflection of your original function over your line y is equal to x. So as you see this red line, think about the blue and the green lines are kind of like mirrors, right? They're mirrors of each other, so you can see them on opposite sides of that red dotted line that we drew. So now what we're going to do is we're going to take this same f of x function and we're going to find the inverse algebraically. So remember that f of x is technically the same thing as y. So if I'm going to switch the positions of x and y, I'm just going to switch the variables. So where I had the y is now going to become an x, and wherever I had the x is now going to become the y. I'm going to use algebra to solve for y. So I'm going to subtract 1 from both sides, and then I'm going to divide both sides by 4 to get y by itself. This new equation represents the inverse of your given function, and then if we want to use the specific notation for representing the inverse of our function, it kind of looks like our f function but with a little -1. That just means the f inverse notation. So how I'm going to say this is f inverse of x is equal to, and then x minus 1 over 4. Okay, in example 2, let's do another algebra problem. So remember that f of x is the same thing as y. I'm going to switch the positions of my x and y variables only, and now I'm going to solve for my new y value. So I'm going to add 1 to both sides. I'm going to divide both sides by 2. Now at this point, you're saying, well, hey, what do I do with that y to the third power? Well, let's undo that power. So if it's cubed, right, I want to take the cube root of it. So that way I can cancel out that power, and I am left with just a y. I'm going to get the cube root of, and then that whole quantity of x plus 1 over 2. And remember, with that specific inverse notation, I've got f inverse of x, and then I have the cube root of x plus 1 over 2. Okay, here in example 3, I'm given a graph of a parabola. Here I have h of x, and I have x squared minus 5. Now I could use ordered pairs that I can find from my graph, and I can also use the line y is equal to x to help me to sketch the inverse. So what I'm going to do is I'm going to find 3 points for right now. You can find more than 3, you can find 5 if you'd like. And I'm going to go ahead and take those points. And to find the inverse, I'm going to switch the x's and the y's. This will help me to get 3 new points, which will then help me to graph a parabola. Now remember, this shape is going to be pretty much the same, right? It's just going to be on its side, okay? So we don't want to make it look like a line. We want to make it more of a U-shaped curve. Okay, here in example 4, we want you to think about this relation. Now, we want to think and kind of remember back to when you first learned about functions. Remember that a relation's a function if and only if each input has exactly one output. So let's just look at this relation. Is it a function? Yes or no? Every input, 4, 2, -5, and 3, they each have one output. So this relation is a function. Now, if I want to find the inverse of this relation that I have, well, what have we been always looking and starting off as? Switching the x and the y values. So I'm going to switch my x and y values to become 1, 4, 6, 2, 4, -5, and then 6, 3. So there's my inverse. Now look at B. Look at the inverse. Look at these new points that you now have. And ask yourself, is the inverse a function? Well, in this case, it's not. And the reason being is that 6 has two different outputs. So this inverse is actually not a function. So the relation is a function, but its inverse is not. So when you look at a graph, remember a relation can be a function and it has to pass the vertical line test. Now, to determine whether or not my inverse should be a function, well, hey, if it was vertical line test for a relation, then it probably should pass the horizontal, the opposite, the other one. It has to pass the horizontal line test. So remember, no repeating y values. So let's look at some examples of some graphs in example number 5. So here you got 3 functions, and we want to determine whether or not the inverse of each function is also a function. So let's see if it passes the horizontal line test. In letter A, yes, it does. I only touch the graph one time. In letter B, I draw one horizontal line. It touches my graph twice, so the inverse is not a function. In example C, draw one horizontal line, so the inverse of letter C is not a function. So now if your graph passes both the horizontal and the vertical line test, it's actually called a one-to-one function. So that example is actually letter A. The function as well as the inverse both pass the horizontal and the vertical line test, so letter A is actually a one-to-one function. Okay, so some things to remember. Whenever we think about inverses, we're switching the x and the y values or the x and the y variables if you're trying to solve algebraically. And if you want to know whether or not the graph of the inverse is a function, then it has to pass the horizontal line test. Okay, I hope this video was helpful and now you feel a lot more comfortable finding the inverse of a function graphically as well as algebraically. Thanks for watching and have a great day.